Good afternoon. It's good to be back here at Upperside. I was at OFC last week as well, and I think between last week and this week so far, I've realized there's one thing growing faster than AI investments, and that's the number of slides that we use to talk about it. So I'm going to talk to you about these AI-ready approaches for data center connectivity. So first, let's set the stage by talking about the ecosystem. So obviously, the cloud providers are, there's massive investment coming from the cloud providers, but it's not just, the hyperscalers, it's also these neo-cloud providers or neo-scalers that are offering GPU as a service, that are helping to drive investment. And then, of course, you have the model builders, the OpenAIs of the world, the Anthropics, Google Gemini, et cetera. And collectively, these stakeholders are all really part of building these AI factories. And then you have, the enterprise and consumers, and they're the ones that are ultimately going to pay, for the use of these models and all that investment. They're essentially part of that AI monetization. And then, of course, the service providers. The service providers play a key role, right, in helping to interconnect these end users to the AI models, particularly as we shift to more AI inference, right? And when we talk about users here, a user, the service providers connect the users to the cloud. A user could be a human, right? Or a user could be an agent with more and more agentic AI. So through the course of the rest of the presentation, I will talk about the user-to-cloud segment of these networks, but I'll also talk about, of course, the cloud-to-cloud, where there's more east-west traffic happening. So double-clicking on this ecosystem, let's focus on, so the AI dynamics, what impacts is that having on service providers on the left-hand side, okay, and the cloud providers on the right here. So with service providers, are looking to introduce new services naturally that are more geared towards, enabling AI. We've seen, for example, Verizon in the US has announced an AI Connect service. In Europe here, we have service providers like Liberty Global, Vodafone have announced partnerships with Google where they're, providing a joint AI stack, right, set of offerings. So new services. They're also upgrading their infrastructure, right? Service providers, with the growth in inference that other speakers have referenced, service providers are going to have to upgrade their infrastructure. Multimodal AI will generate even more capacity. They need lower latency infrastructure upgrades. And then finally, they're transforming their operations, right? So leveraging more AI ops to simplify operations, leveraging more autonomous networking. My colleague Tim Pearson spoke about that some this morning. And then on the cloud side, it's really about the race to build the best models, right, and the best ecosystem. So as I mentioned, massive amounts of CapEx. I think the figure in 2025 was $600 billion in data center investments in 2025. And that's not just happening in the US, it's happening in Europe as well. Last month there was a Paris AI summit I read, and President Macron pledged, like $109 billion in the coming years for AI investments in France. So because of reasons of data sovereignty, et cetera, this is really a worldwide phenomenon. And then finally, of course, data center redesign. So these GPUs in the training, very compute intensive, very bandwidth intensive, and of course, very, very, there's a lot of power constraints. I was at OCP Summit last year, and Meta commented that they probably put it best when they said, power is this industry's Achilles heel. And you've heard that, multiple times throughout the day today. So you've heard my the prior presenters talk about these segments of the network, right? Scale up, scale out, and scale across, where the grid can't give enough power to even one, to any one location with these large gigawatt scale data centers emerging. And so that gave rise to the scale across. And this is, what we're calling the back end portion of the network. And that's in contrast with the front end portion of the network, which is where the traditional DCI has happened, right, with with applications running on CPUs, compute. The AI portion of the network is also connected to this front end, so we'll be talking more about DCI use cases. And so that's really the first wave of investment of AI. It's the training. But as that first wave continues, there's a new wave that we're focused on, which is, again, inference. And again, that's about taking these trained models, deploying them out at the edge closer to the end users, businesses, consumers who will utilize them. And it's about distributing them, right? So we're going to have edge clouds that are more distributed. Last week was this GTC conference, and Jensen Huang, talked about how the inflection point of inference is here, right? So this is where there's going to be a significant amount of growth. And of course, this traffic has to traverse those service provider networks. So this is where, service providers become an important part of this value chain. Have to upgrade that infrastructure, looking at introducing those new services, and really become a part of the key ecosystem here, right? So if you look at that topology that I shared, there were a number of examples of data center interconnect. So now let's look at what are the technologies, what are the architecture models that have been used to deliver DCI over the years. So if you go way back, originally, service providers were using DWDM chassis, vertically integrated, typically from a single vendor, and they're in a telco, chassis form factor. But then fast forward to, 2015 or so, cloud providers, hyperscalers started interconnecting their data centers, wanted a more disaggregated approach, right? More of a data center form factor, where still utilizing embedded modems or embedded optics, okay? But using open interfaces, programmatic interfaces to tie in with cloud providers. So that was a new model. Now today, we have, of course, coherent pluggables. So, starting in 2021, 400 gig ZR, ZR Plus were introduced. And those 400 gig pluggables can be deployed in all of these models, right? So whether it's the fully vertically integrated DWDM chassis, the disaggregated model, the router, you have coherent pluggables deployed in all of them. Ciena, we have a lot of experience with all these models. We've deployed them all in production. In fact, Deloro, in their last market report in Q4, talked about, they reported that we have #1 market share position in this space. Now, if we zoom in on the router model, right, with coherent pluggables, the volume is with 400 gig today, but going forward, we're going to see more and more 800 gig, where that's where the growth will be. Today, still the volume is 400 gig. In the future, of course, 1.6 terabit coherent pluggables, that will necessitate, routers with ASICs with 200 gig SerDes, but, they're coming in the not too distant future. In the meantime, one of the things we've done is we've taken that embedded modem or that embedded high performance optic, and we've integrated it into our router. So the same advantages you get from IP optical convergence in terms of cost savings, power savings, operational savings, we've achieved by taking an embedded modem, putting it in the router, while we await for those 1.6 terabit pluggables to arrive. And, the embedded modem gives you this high performance, so it'll achieve greater reach than what you'll be able to achieve with a pluggable. But the other thing it does is it has a lot of spectral efficiency. So even in shorter reach situations for operators that need that spectral efficiency, maybe the cost of leasing fiber is much higher for them. So they appreciate that spectral efficiency. You can get a lot more capacity on a fiber. And for some cases, it's an overall lower cost per gig. So next, let's look at, I'm going to talk about a few different use cases for data center connectivity. We'll start with the 1.6 terabit example. So one of our customers, Dark Fiber Africa, issued a press release. They implemented this trial, which was the world's first example of 1.6 terabits on a router in a single wavelength. They are an open access provider, so they They provide wholesale connectivity with a lot of the cloud providers and services being brought to the market in South Africa. Cable landing stations coming in here. They really need to scale their network, so they wanted to go to 1.6 terabit between their regional cores, between data centers. And for them, scaling is also about scaling services, right? So the services that are coming off of these access or aggregation rings, it's also about being able to support thousands of those services. And they're modernizing their network, so they're moving to segment routing as well in the process. So that's one example of a data center connectivity use case, that one using the 1.6 terabit. Another one is, let's look at an enterprise example. So this is a large enterprise. This is a healthcare pharmacy provider, and they're running latency-sensitive applications, including AI, between their campuses, and they're utilizing service providers to be able to interconnect their cities. And one of the challenges that they have is that when there's a failure in the optical core of one of those service provider networks, they end up seeing a spike in latency because the traffic ends up taking a much longer route. And so what we've architected for them is a solution that looks at measuring latency in near real time and automatically always picking the lowest latency path. So we're utilizing FlexAlgo for that. We're monitoring latency via TWAMP, but you could do it with Y1731 as well. And we're using that policy. And it's not just latency, they're also looking at, utilizing affinity and looking at high bandwidth to set policy to put high bandwidth on different links. So kind of zooming in on that, it's an EVPN-based service, again, utilizing segment routing with FlexAlgo, can be SR-MPLS, can be SRv6. And that transition to the lower latency path, when this happens, is hitless, right? So you can think of this as, a form of autonomous networking, as you will. We can also separate that high bandwidth traffic that's non-latency sensitive and put it on other links. And finally, you can also, secure this with MACsec. So AES 256 encryption integrated into the same platform at wire speed across all the ports can also be used to secure this. And that itself is the cryptographic algorithm is quantum safe. If you use, as you may know, if you use like manually shared keys. What's not quantum safe today are these dynamic key exchange mechanisms, but there's new emerging mechanisms being introduced that are quantum safe. So that's an enterprise campus example. And then finally, this is an example of a data center operator or exchange provider. So here they're interconnecting their exchange facilities within a given metro. And these exchange facilities are very power constrained, very space constrained. And so they needed something that was, low on space and power, but also very low latency, because you can imagine, again, inference applications needing low latency within a metro. So they turned to, in this case, they deployed FlexE. And in particular, it's layer 1 mapped FlexE. So that gave them very low latency. It's like 1/4 the latency of a typical layer 2 or layer 3 routing hop. It also gives them complete service isolation so that one service has, won't have any impacts from, regardless of what's happening on other services. And this is also integrating coherent plug. So in a 1RU form factor, you have this low latency, you have this service isolation, and you have the coherent pluggables providing 400 gig coherent across the network. Okay, so wrapping up, you've seen how these network architectures are changing based on AI dynamics. I talked about how as we shift from training to inference, it's going to create a lot of opportunities for service providers, for enterprises alike. I gave a number of use case examples, and so hopefully that's all useful to you. Okay, with that, thank you very much.